So as we get into the measurement unit, it is a good idea just to take a moment and review the Pythagorean theorem, because quite often within the measurement unit, you're going to be needing to use the Pythagorean theorem to help you find some missing sides, or even when we get into 3D geometry and we get into cones and pyramids, you're going to be needing to use the Pythagorean theorem. So remember that Pythagorean theorem is for right-angled triangles. And it talks about the fact that the square of the hypotenuse is equal to the sum of the square of the other two sides. So typically when we use Pythagorean theorem, we label a triangle with sides A, B, and C. And C is always going to be called the hypotenuse. And the hypotenuse in a right-angled triangle is always the longest side. A and B, it really doesn't matter if you put A as the height and B as the base, or B as the height and A is the base. The only one that really matters is that C must be the hypotenuse. So the formula for Pythagorean theorem is C squared is equal to A squared plus B squared. And again, if you recall from last year, you spent some time investigating that. And basically all that means is if you drew a square on the side here, and you drew a square on this side here, and you added those two areas together, they would be equal to the area of the square that you would draw here. So it's kind of an interesting relationship. Now sometimes you don't have to solve for the hypotenuse. Sometimes you're given the hypotenuse and you have to solve for either A or B. And when that happens, you have to rearrange this formula. So when I rearrange this formula, let's say, for example, I want to solve for A. That means I don't want this B squared here. And so to get rid of it, I need to subtract it from both sides. And so my rearranged formula is going to look like this. So if I'm solving for a side other than the hypotenuse, I would use the formula A squared equals C squared minus B squared. Now remember how I said that A and B are interchangeable? So really, you could also write B squared equals C squared minus A squared. Both are correct. So this formula here, this first one, is what I would use when I am solving for the hypotenuse. And this one is what I would use if I'm given the hypotenuse and I'm solving for a different side. So let's look at a couple examples. So in example 1 here, for part A, I'm asked to find the hypotenuse, which means I'm going to use this formula here. Once I write down my formula, I'm going to substitute what I know. So it's always important, step 1, write the formula, step 2, substitute, step 3, let's solve it. And you can start to skip some steps in the solving process. This is not something that you have to solve, every single little step. So that's 59, 65, I believe. Now, you can't square root 65 and get a whole number. So you're going to end up with a decimal. And if it doesn't say, we'll always round to 1 decimal place. And just give me a second as I figure out. So that's going to equal 8.0622 blah, blah, blah. So if we round to 1 decimal place, or to the nearest tenth, that's going to be 8.1. And so I would leave my answer as 8.1. Even to be more accurate, you might want to do this squiggly equal sign, which means approximately equal to, because it's not actually equal to 8.1. For this second example, or part B, we'll notice that we're given the hypotenuse and we need to solve for one of the other sides. So we're going to use this formula, which is the rearranged formula. And again, our next step is going to be to substitute. Remember, C is always the longest side, or the hypotenuse. And then we're going to show our work. Again, you can skip some of these steps. And we will end up, I believe, with 95, but I'm going to double check that. Yeah. And then, again, we won't be able to get a whole number answer, so we will end up with a decimal. And we end up with 9.7467, blah, blah, blah. So if we round that to one decimal place, that would be 9.7. Don't forget, if these questions had units, our answer would need to be having units. Also notice a couple things. These steps here all say b squared. These two do not. And that's because as soon as I square root, remember what's the opposite of squaring something? It's square rooting it. I get rid of the squared because the square root of b squared is b. So be careful with that.